This is a video to support higher engineering science, electronics and control, and specifically we're looking at the operation of a MOSFET within the analogue electronics part of the course. So we've got a little circuit set up here. We've got a 12 volt supply. Here's a MOSFET here, and the output we've got a little lamp. Basically what we're going to do is we're going to measure some different aspects of how the circuit works using a multimeter, and essentially this little device here, this gap in the circuit, is going to act like a switch, because various times I'll start to close it and we'll see the lamp lighting up, and we'll see a little bit about how the thing actually operates. So first of all, I'm just going to place a transistor there in the position of the MOSFET, and I'm just going to draw your attention to the connections that's there as part of the pins for the MOSFET, where we've got the base feeding in here, emitter coming down towards the 0 volt rail in the circuit, and the collector, which is being fed by current coming from the top of the circuit from the 12 volt supply. We're quite familiar with that. However, if I remove that now, and we can compare that to the MOSFET, where instead of the base we've got the gate, instead of the emitter we have what we call the source, and instead of the collector we have what we call the drain. So G for gate, S for source, D for drain. What we're going to see here initially is we're going to have a little measurement of the voltage between the gate and the source connections as the lamp lights up. That's very much the same as the voltage dropped between the base and the emitter in a transistor, and we know from National 5 that VBE, that voltage that's dropped between the base and the emitter, is 0.7 volts when the transistor is fully saturated. What we're going to see here is that the MOSFET will saturate as well, but it saturates differently, and it will vary depending on the circuit and the conditions that it's acting under, and indeed the type of MOSFET that's actually in there as part of the circuit. If I switch on my multimeter, we can actually see that there's already a voltage dropped between the gate and the source, and it's hovering just below 2 volts, and currently there's nothing happening at the lamp. And I'm going to use my finger closing over these two terminals to act like a switch, which is going to allow a slight increase in the voltage, and we can see there that the voltage is creeping up closer to 2.1 volts. The lamp's not doing anything yet. As it gets upwards just over 2.2 volts, the lamp's starting to light up, and if I put a wee bit more pressure down in that up towards 2.3 volts, the lamp's illuminating. So the voltage at which this starts to illuminate, where there's a voltage, the gate source voltage is just doing enough to cause the lamp to light up. It's what we call the threshold voltage. It's the threshold at which there's enough voltage there to power the MOSFET so that we start to get a current flowing through the drain. However, if I make my finger damp, then that will let me do that, and you can see how the voltage really increased and the brightness of the lamp really increased, but you can also see the voltage is dropping quite dramatically, and that's because my finger's drying, which means it's not such a good conductor anymore. And fairly soon you'll see the lamp starting to dim a bit again, and round about 2.4 volts or thereabouts the lamp started to dim. So 2.4 volts is probably around about where the saturation voltage is. The saturation voltage is simply the voltage at which we're getting the maximum operation of the lamp. So now we're going to investigate a little bit about what happens to the voltages dropped at the output and the current sort of flowing through the output of the MOSFET circuit. Right now we're measuring the voltage that's dropped from the 12 volt rail down through to after the source connection of the MOSFET, which is effectively taken down to the 0 volt rail, and it's not a big surprise to see that the voltmeter is reading almost 12 volts, 11.69, 11.7 volts. And if we do enough to illuminate the lamp, then there's a tiny little change there, but effectively it's much the same voltage that's there. So the whole of the 12 volt supply has been dropped across there. However, if we now start to investigate a little bit what the measurements would be in what we call the drain source voltage, the connection between the drain and the source. Now, before I go much further here, it might be useful to explain that the drain and the source effectively form a resistor as part of this circuit. So the lamp has got a resistance because it's a lamp, it's a resistive component, and between the drain and the source effectively forms another resistor as well. So effectively we've got two resistors in series in this circuit. So right now, with no conduction and the lamp not illuminating, we can see that we've got 11.6. So again, the vast majority of the 12 volt supply is dropped across the drain and the source connection here in the MOSFET. If I start to illuminate the lamp, and we can see that the voltage dropped across it has dropped right down. I'm pushing down fairly hard. Let's go for a wet finger. The voltage has become very, very small, 0.02 volts. If I do a quick change in my multimeter in the connections, then there we go, we're measuring right across the two parts again, so we're up close to 12 volts. And if I reconnect this one here at the other side of the lamp, then we're measuring the voltage dropped across the lamp, very, very small, 0.04 volts. And as I start to push down on it to illuminate the lamp, we can see that more of the voltage drops across it. And again, if I wet my finger, then we're getting almost all of the voltage dropped across the lamp. So this backs up a lot of our learning about what happens to voltage in a series circuit, because effectively, as I said earlier, this is a resistor and this is a resistor between the drain and the source, and the two things are in series, and we can see how the 12 volt supply is dropping over those connections. So the voltage here at the lamp, when we're referring to MOSFETs, is what we call the VD, short for voltage dropped across the drain, and that's what we're seeing dropped across the lamp. And the current that would flow through that is ID, the current flowing through the drain. That's going to become quite important in a little moment. The voltage dropped all the way across between here and the source connection is what we call VDS, the voltage dropped between the drain and the source. And similarly, when we're referring to current there, we're referring to the IDS, the current that flows all the way from the top here through the drain down towards the source. Now we've got to bear in mind when we're doing calculations for these things that this is its own little resistor between the drain and the source, and this is the other resistor here. But what we also will find is that the reason why this operates the way it does is because the resistor that's effectively there between the drain and the source is a variable resistor, and as the VGS here is under the threshold voltage for it's not doing anything, we've got basically an infinite resistance here, which means that no current's flowing through it. And then as we get to the threshold voltage for VGS and the lamp starts to illuminate, and that means that the resistance is now dropping to such a point where we can get a current beginning to flow, and hence why the lamp illuminates. And then when we get to saturation, when it's not going to become any brighter than it already is, then effectively what's happened is that the resistance between the drain and the source has gotten really, really small, and that's what allows a large current to flow.